See here. So this is going to be the constant resistance circles. Constant resistance circles, what you have in the circular ones are constant resistance circles, and this one is the same interpretation. You see, when you are plotting with respect to impedance, it is going to be straight line. But the same thing, if you are plotting with respect to tau, it becomes a circle. And I am not calling it as a concentric circle because concentric circles will have same center, but these circles are not concentric, but they all meet at the same point. They all have a common point of contact. So x-axis is going to be the real value of the reflection coefficient, y-axis is going to be the imaginary value. So we are going to have one circle of this sort. This is going to be constant resistance circle, and see constant reactance circle. So if you plot in impedance scale, you have vertical horizontal lines, which is available as you see in the figure, but you transform them into tau plane, you get beautiful circles. See, the circle is actually very big. It is going like this. Okay, so but to restrict that in a single Smith chart, we are taking only portion of the circles. So all these circles, all these arcs are parts of circle. Okay, so don't think that I just cut this Smith chart in a fashionable way. No, so it is a part of the big circle what you have. So when you this diagram and the previous diagram, if you combine, that is going to be your Smith chart. So you will have constant resistance circles as well as constant reactance circle. So your Smith chart will be looking like this. So I am just drawing the superimposed version. So the inside lines plus the concentric circle. So if these two combination is going to be your Smith chart. Okay, so that is what is required. So see here, Smith chart is the plotting of both constant resistance and constant reactance circle in the tau axis. So remember, tau is our axis of reference in the Smith chart. And center of Smith chart corresponds to zero reflection. You know, when you go to high frequency, the problem of matching, impedance matching will occur. Impedance matching means if you don't properly match the source and load, loss of power will happen. Or I can say if you match them perfectly, maximum power transfer will happen and reflection will be zero. So the center of Smith chart, see here, this exact center of Smith chart corresponds to the point where you have zero reflection. Or I can say the impedance is perfectly matched. And see, if you take your real axis, all the impedance above the real axis is going to be, see here, the bottom half of Z plane maps bottom half of unit half of tau plane, and all capacitance are found there. So when you go below this real axis, the reactance value is negative. You know, capacitance have negative reactance. So the bottom of Smith chart corresponds to capacitance. And the upper half of Smith chart will have positive reactance, and you know inductance will have positive reactance. So the upper half of Smith chart will correspond to L values. So remember, in a normal Smith chart, when you are going to plot the value of inductor, you have to naturally plot it above the real plane. When you want to plot a value of capacitive reactance, you have to plot the value below the real plane. Okay. So real plane is our reference. Above and below will correspond to capacitive and inductive impedance. You see here, the upper half will correspond to the inductance. So small circles of constant resistance will progressively, they will increase and become large resistance values. So initially you can see how the circles are very small and they will constantly grow and become as big as possible. So tau is equal to -1 corresponds to zero resistance. Zero resistance means you know short circuit. So remember, when you're short circuiting your network, the reflection is -1. The -1 indicates the reflection is 100% with a phase shift of 180 degrees. So OC and SC are not ideally required for a circuit because it results in full reflection. 1 means 100% reflection, and -n indicates reflection plus a phase shift. Okay. And tau is equal to 1 corresponds to infinite resistance, or you can call it as open circuit. So for open circuit, 100% reflection. For short circuit, 100% reflection plus a phase shift of 180 degrees. So understand these basics. So this is what is required in Smith chart. So Smith chart is just given to understand how marking impedance is going to be very simple in your high frequency analysis. So Smith chart is all about this. And what you do with Smith chart and S parameters are